Alright, here are the quiz 4 solutions. I decided to redo the solutions because the quiz didn't go very well for a lot of people, so I thought a little extra explanation might help folks out a little bit. So the first problem, linear approximation. I wanted to kind of draw a picture of what's going on. You didn't need to draw this picture to get the answer, but if you kind of remember this picture of what's going on, it's a lot easier to do the calculations. Makes it a lot less likely that you'll plug in 1.98 where you're supposed to put in 2 or 2 where you're supposed to put in 1.98 or whatever. There's a lot of confusion on what you plug in where. And maybe if you remember this picture, then it's not just memorizing what goes where, you kind of understand what goes where. So anyway, the idea of linear approximation. What we want to do is we want to take a guess at what f of 1.98 is. In this problem, we could figure out exactly what f of 1.98 is. Here's f of x. So f of 1.98 you get when you stick 1.98 into this for x. So in the picture right here, this blue curve is f of x, 2 to the x over natural log of 2. And when x equals 1.98, the height, the thing we're going to estimate, is this big blue dot right here. This blue dot right here is f of 1.98, which is exactly whatever this number is here. But we kind of pretend, in linear approximation, we pretend that we don't know what this number is. Pretend you don't have a calculator, whatever. You can't calculate this. So what you do is you take advantage of the fact that close to 1.98, 2 in this example, is a number that we can figure out the derivative of. And since we can find the derivative of this function at 2, we can come up with the equation of this red line right here, the tangent line, 2f of x at x equals 2. And once you have the equation of this red line, what we'll do is we'll estimate this big blue dot right here, f of 1.98, using the point on the line that we come up with, and that's the linear approximation at 1.98. So our answer will be this little red dot, which is our approximation for this big blue dot. So maybe that helps a little bit. So if you think about all that idea, the first step we got to do is we got to come up with the equation of this red line right here. The way you come up with the equation of a line, same thing we've been doing. You need two pieces of information. You need a point on that line, x1, y1, and you need the slope. The way we'll find the slope of this red line is we'll take the derivative of the blue curve, and then we'll evaluate that derivative at 2. Right? The derivative, it's the slope of the tangent line at that point 2. So what our m will be f prime of 2. And then to come up with the point we'll use is this little point right here. This point is on both the tangent line and the curve. So it's a point on the line, but the way we'll get its coordinates is by thinking about it as a point on the curve. Its x value is 2. And its y value, because it's on this blue curve right here, when you stick in 2, you get out 2 squared divided by natural log of 2. That is 4 over natural log of 2. So now we have a point and we know how to figure out the slope. We just need to figure out f prime of 2. To figure out f prime of 2, you first find f prime of x. A lot of people had trouble with figuring this out. I think what happened to a lot of people is they looked at this and they saw the quotient rule, which is fine, you can do it. It's more than you have to do, but you could do it that way if you want. But the key thing to note is that if you use the quotient rule, the thing on the bottom here is just a constant. Natural log of 2 is a number. Plug in natural log of 2 in your calculator, it'll spit out a number, it'll tell you what it is. There's no x's in here, there's no variables. So because this is just a constant, when you take its derivative, it's 0. So if you use the quotient rule, you're going to have something minus 0 over something. And a lot of people didn't realize that this was a constant. They tried to call its derivative maybe 1/2, or what else did I see? 2 over x. I saw a lot of different things of what people thought this derivative was. But really, because this is just a constant right here, its derivative is 0. So like I said, you could use the quotient rule, but maybe an easier way is if you realize that that's a constant, think about this function as this constant times 2 to the x. Because if you think about it as a constant times a function, the derivative is easier to take. You leave the constant alone, and then you take the derivative of this 2 to the x. Derivative of 2 to the x is 2 to the x times natural log of 2. And what's nice about that derivative is this natural log right here and this natural log right here cancel out. And so that gives us f prime of x is just equal to 2 to the x. And therefore f prime of 2 is 2 to the 2, or 4. So now we have all the information we need to calculate the equation of this red line. That won't be our answer, but that'll get us really close to our answer. So we have a point on the line and a slope. I think the easiest way to do it is to use point slope form. If we plug in all of this information into this formula, we get y minus 4 divided by natural log of 2 equals m, which is 4, times x minus 2. And you can simplify this a little bit. Got 2 steps. First, distribute the 4 through. So we got 4x minus 8. And then add the 4 divided by natural log of 2 to both sides to get y equals 4x minus 8 plus 4 divided by natural log of 2. So it's kind of a mess, but the way to think about this is it's y equals m x plus b. So we do in fact have the equation of a line, specifically this red line right here. And now that we know the equation of this red line, we just want to know the height of this red line when x equals 1.98. Right? This point right here is what we were looking for. So to figure that out, all we have to do is change this x into 1.98. So our linear approximation, which you usually write like this, although if you didn't, I don't care, is equal to 4 times 1.98 minus 8 plus 4 divided by natural log of 2. And I think I just told you to leave it as a big mess like this. You could simplify a little bit, but you won't ever get it all the way down to just a number. So might as well just leave it like that. So I think that was the problem. The number 1 gave people more trouble than number 2, generally speaking. So there's kind of a long drawn out solution to it. Hopefully that helps you guys out. Moving on to number 2. People did better on this one, which is good. It's a difficult derivative to take. Part A, we just want to find the derivative. I say just because there's nothing else to do, not because it's easy. What we actually have going on here is a chain rule inside a chain rule, and then a product rule inside that. So the way to think about it is the outermost function is this log base 2. I put it in red here. And then kind of the next function is this 3. And then the innermost function is this x cosine of x in green. So when you look at this, if you can kind of see these colors, that'll help you deal with the chain rule because there's so much going on. So to take the derivative, we got g prime of x equals, we'll first take care of the log base 2 of something. The derivative of log base 2 of something is 1 divided by that something times the natural log of 2. So we got 1 divided by 3 to the x cosine x times natural log of 2. And then we're still not done. We still have to take the derivative of 3 to the x cosine x. So maybe I'll write that like this. This part's done. We still have to take the derivative of this part. But we can do that. Leave this stuff all alone. See, to take the derivative of 3 to the x cosine x, you should think about this as chain rule again, the outside function being 3 to the x, the inside function being this x cosine x. So the derivative of 3 to the x, looking up here, is 3 to the x times natural log of 3. So the derivative of 3 to the x cosine x will be 3 to the x cosine x times natural log of 3. But then you're still not done. We've just taken care of this function, the blue part. We still have to take the derivative of this green part here. This green part, x times cosine of x. Hopefully you see the product rule there. I think people did pretty well on that part. The first function's x, the second function's cosine of x. Derivative of x is just 1. leave the cosine alone, and then we want to add to that, leave the x alone, and then the derivative of cosine of x is negative sine of x. So you get this big mess for your answer. I said no need to simplify, so this is a perfectly good answer. However, if you really want to, you can cancel out this 3 to the x cosine x with this 3 to the x cosine x, and then it can be written a little neater as cosine x minus x sine x times natural log of 3 divided by natural log of 2. But again, this second to last line is perfectly fine. This is just as good as this line since I said no need to simplify. And one other little note, maybe I can do this over here on the side. A completely different way to attack this problem is if you remember your log rules. So I wrote this problem so that you don't have to know the log rules, but if you happen to know them, it might save you a little time. I saw a few people do this. And basically it says if you're taking the log of something raised up to an exponent, you can bring that exponent down in front and multiply it by that log. So we could take advantage of that here. You could think about this as 3 raised up to the x cosine x. So you can bring the x cosine x down in front. And you can say that the log base 2 of 3 to the x cosine x is equal to, bring the x cosine x down in front, x cosine x, and then you're left with log base 2 of 3. And what's nice about this form right here is that log base 2 of 3 is just a constant. So what you end up with is log base 2 of 3 times the derivative of x cosine x, which is what we figured out over here, cosine of x minus x sine of x, which I don't really have room to write in there, so I'll use arrows. And this right here is equivalent to this right here. Maybe it looks the exact same, except instead of natural log of 3 over natural log of 2, we wrote log base 2 of 3. But if you remember the change of base rules from the homework, we had to use this a couple times. That's just exactly the change of base formula. Natural log of 3 divided by natural log of 2 equals log base 2 of 3. So either of these answers, or any of these three, I suppose, are perfectly fine for number 2. If you happen to get this answer for number 2, it makes it the easiest to get to part B. But I'll suppose that you left it right here, because that's probably what I would have done. So don't simplify, so don't bother simplifying when I do part B here. So we want to figure out g prime of 0. We figured out g prime of x. Well, again, we'll use this line for g prime of x. So the way you figure out g prime of 0 is you put in 0 for all the x's. So we got 1 divided by 3 to the, this is just 0, right? 0 times anything is 0. So 3 to the 0 times natural log of 2. Multiply that by, again, 3 to the 0, natural log of 3. And then we got cosine of 0. I think I told you that's equal to 1. Minus 0 times, this ends up being 0 also, but it doesn't matter because 0 times anything is 0. So you get this mess here. And then if you remember that any number other than 0 raised up to the 0 power is just equal to 1, this is a 1 and this is a 1. So this all simplifies to just natural log of 3 divided by natural log of 2. And then applying our change of base formula, this right here is the same as log base 2 of 3. So g prime of 0, in fact, is of this form, where a equals 2 and b equals 3. So that's the end of quiz 4.